Hello, welcome back to SCAMP. Today we're going to be trying out my new development environment. Day 6, signals and noise. Something is jamming your communications with Santa. Oh, okay. There we go. Something is jamming your communications with Santa. Fortunately, your signal is only partially jammed, and protocol in situations like this is to switch to a simple repetition code to get the message through. In this model, the same message is sent repeatedly. You've recorded the repeating message signal, your puzzle input, but the data seems quite corrupted, almost too badly to recover. Almost. All you need to do is figure out which character is most frequent for each position. For example, suppose you had recorded the following messages. The most common character in the first column is E, in the second A, in the third S, and so on. Combining these characters returns the error-corrected message Easter. Given the recording in your puzzle input, what is the error-corrected version of the message being sent? Sounds straightforward enough. Okay, 6,000 characters is enough that we can easily read the input into memory. Since they're all a fixed length, we could just read in the file as a string and address each line with a fixed offset. So I'll write down that. It's 5,382 characters. Right, let's get started then. So in this environment, when you type a line, the line is then compiled and executed immediately. So, for example, if we put hello world, it will compile and execute the line immediately. I mean, as quickly as it can compile. And we can create functions as well. So, for example, square is a function of x that returns x squared. So square of 12, which now has to itself be compiled, although I would like it to be able to execute simple calls like that without compiling them. Square of 12 is 144. Okay, great. So the first thing we want to do is read the input. So I'll use the text editor to write actually, first we'll have some memory allocated for the input. Let's give it 6K. I wonder if I want a way to batch up input lines so that I can only pay the compilation cost once. That might be interesting. Which is quite funny because that's the exact opposite of what this environment is supposed to do. If the extreme case of batching up input lines and only running them once is just writing out the program in a straight line. Probably going to edit the pauses out of the video, because that'll be annoying to watch. So we simply want to read the file called input into memory starting at the global name input. So we'll open input for reading. And then how much did I allocate? Was it 6,000? So that should do the job. Okay, 5,382. So the input is now in memory. So how long was each string again? If we... One, two, three, four. 1, 2, 3, 4, 5, 6, 7, 8. 8 characters per string with a new line at the end. So there's a new string every 9. Let's put n equals 5,382. Okay, now I'm going to have to silently meditate to work out the best way to solve this. So we'll just do it in one big function. 5,382 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 + 1 = 6,000 So to start with, we'll just print out the first 4 lines to check that we're reading the input correctly. I think that should say S8 equals 0. Otherwise we're going to overwrite the first character of the next string. Okay, that looks about right. So for each character, we then need to keep track of how frequent is each letter. So I can't necessarily remember how to use vzmalloc. Near the bottom. You just put an array of sizes. Okay. So we've got 8 positions and 26 possible letters in each position. Okay. Don't need that, don't need that, don't need that. So frequency of the jth character and sj minus a gains 1. Did v3 need me to specify the sizes? Not sure if I've ever used v3. I normally just don't bother freeing anything. But in this case we really have to, because we're running in the same address space. Okay, it looks like it just wants the same sort of argument as vzmalloc took. Okay. Need to initialize j to 0. So then if frequency of I, j is greater than the frequency of I, ch equals j, that will find us the character that is most frequent, and then we can simply print it. Plus a. Great, maybe that'll work. Yes. Damn, that's a problem. When the yeah, that's obviously wrong. When the function fails to compile, it doesn't update the stored definition because the stored definition still the version we're looking at now matches the implementation of part 1 that's actually in memory, which means we've lost all the code we just wrote. So that's annoying. That definitely needs to be fixed. Okay, I'll try and write it again. Right, what do we reckon? Is that right now? Or at least is it going to compile? I, J and CH are all declared. Got semicolons after our blocks. Probably compile. What sort of unsafe changes? Great success. So this might be the answer, or it might crash the computer. Kind of surprised that would take so long, because it shouldn't have to compile this. Since it's just the name of a global called with no arguments, it shouldn't run the compiler. Yeah, it crashed the computer, okay. Fortunately, I've made the environment save a binary image of memory into the file called project after each successful line. So now we should be back at the state we were in. I thought it was kind of elegant to use functions to launch the editor. So there where I write kilo part 1, kilo is just a function inside the environment that I'm calling. But the downside is you need to compile the function call before you can launch the editor. Oh, did I set n to 5382? Let's just do that. Oh no, that's not going to work because we're still multiplying it by 9 when we add it to input. If I type Control C now, what will happen? Okay, let's try that then. Ah, interesting. Well, it printed out the answer, but then I guess when it called v3, didn't work. Maybe because I've never used v3, it actually doesn't work. Or maybe I called it wrong. Anyway, let's try this. Part 1, QT, BJ, Q, I, U, Q. Oh, hey, great success. Is it called get to? No, maybe get just does. Oh no, I don't want day 2. Cock. You shouldn't type Control C at that thing because the other end of the serial port is still busy spewing out nonsense. So now if I try and get this, it's probably going to not work. Or I'll have to wait until the day 2 one is finished. Okay. I thought there was, oh, it's called part 2, not get to. Okay, part 2, of course, that would be the message. If you hadn't agreed to use a modified repetition code instead, choose the least common letter. Okay, so we simply copy part 1 to part 2 and invert the test. It might have been good if I'd split up those 2 parts so that I wouldn't have to rerun the first step of it. Yeah, for this interactive usage, I think splitting up each function into the smallest it could be is the way to go. So we just need to change greater than to less than. So although we ran kilo part 1, all that does is open up in kilo the source for part 1. If we write a declaration in it that's something other than part 1, when we compile it, it will become something other than part 1, and part 1 will be unchanged. So this is the way to copy a definition. Okay, yeah, I forgot about that. Acothically. Brilliant. Day 6 complete. So what I want to do maybe I got the arguments the wrong way around to v3. Pointer followed by sizes. Maybe we need that. Anyway, I'm not going to. I'll do that a different time. For now, oops, we're already in root, aren't we? I'll exit back to this. For now, I'll just not bother freeing it. Actually, since I have the interactive environment, maybe it would be easier than average to re-implement v3. Unfortunately, I don't have an easy way to copy and paste it in to start editing it. So we'll just delete it for now. Okay, so hopefully we can now run those and they don't crash the computer. Yeah, fine. And now to turn it into a standalone program, we'll write a main function. I could have just done that at the command line actually. All it needs to do is call part 1 and call part 2. Oops, wasn't concentrating there. Okay, whatever. Okay, good. Every time we run main, it will obviously leak some memory. But what I'm going to do now is save a binary that starts main. So save bin is going to save the contents of memory out to a file called day 6, and it's going to start executing our main function. So this is exactly how the environment does the thing where it saves the file called project, which you can launch to get back to the state you were in. Good, so we've saved a file called day 6. Now if we exit the environment and run day 6, it should give us the part 1 and the part 2 answer. Great. So that binary, the day 6 binary, doesn't have a corresponding source file anywhere. None of the source files in this directory are enough to build that binary. What it has in it is the library blob at the start, which has your printf, your malloc, and so on. And then it has all the code from the development environment, which isn't that much, it's like 500 lines of code. So that has an implementation of the REPL inside it and the code to compile your code, load it into memory, and so on. And then it has all of the code we ever typed into root in compiled form, not in source form. And at the very start, it just has a call to main, where normally it would just have the normal initialization code, which ends up starting the REPL. When we use save bin with main, it just writes an instruction at the start, call main. So main runs, and that's how that works. So yeah, that's the development environment. Thanks for watching. Goodbye.